Our story begins at home, not in a house or a city, but on a much grander scale. Our home is a planet, the Earth spinning gracefully through the vastness of space. It is a tiny blue marble in a sea of black. But our planet is not alone. It orbits a star, our sun, a colossal ball of burning gas that gives us light and life. This star is just one among billions, a single grain of sand on an endless beach. All these stars, along with countless planets, clouds of gas and dust, are bound together by gravity. They form an immense, swirling city of stars. This stellar metropolis is our galaxy, the Milky Way. Imagine looking up at the night sky from a place far from city lights. For most of human history, the heavens appeared eternal and unchanging. But with the invention of the telescope, our view of the cosmos began to change. We discovered that the universe was far more dynamic than we had ever imagined. It was a grand cosmic dance, and everything was in motion. This dance is governed by a single universal law: gravity. Gravity is the invisible force that holds everything together. It keeps our feet on the ground. On an even larger scale, gravity pulls entire galaxies towards each other. Our Milky Way is part of one such group, called the Local Group. Understanding motion in the universe is a bit like trying to figure out your speed while sitting on a moving train. They found it not in the stars or galaxies, but in the faint afterglow of the Big Bang itself. In one direction, the CMB radiation was slightly warmer, and in the opposite direction it was slightly cooler. This was a clear sign that we were moving relative to it. We are being swept along in a vast cosmic current. What could be powerful enough to pull not just our galaxy, but our entire galactic neighborhood through space at such a high speed? This mysterious source of attraction was given a fittingly dramatic name, the Great Attractor. Its discovery marked the beginning of a quest to understand the hidden forces that shape our cosmic destiny. The logical next step was simple: point our best telescopes in that direction and see what was there. But when they did, they were met with a frustrating cosmic roadblock. The very thing they were looking for was hidden behind a thick veil. When we try to look out into the distant universe through this plane, it's kind of like trying to see a distant mountain through a thick fog. This region of the sky, where the Milky Way's disk blocks our line of sight, is known to astronomers as the Zone of Avoidance. It was a case of cosmic irony. The mysterious object pulling us across the universe was located in the one direction that was hardest for us to observe. Looking for the Great Attractor was like trying to find a specific ship in a harbor on a foggy night, with all the bright lights of the city glaring in your eyes. The quest to find the Great Attractor became a mission to map this hidden region of space. To see through the dense fog of the Milky Way, astronomers had to turn to wavelengths of light that are, well, invisible to the human eye. By using telescopes designed to detect these longer wavelengths, astronomers could finally begin to peel back the curtain of the Zone of Avoidance. Radio telescopes, often huge dishes that look like giant satellite receivers, can detect the faint radio signals emitted by the hydrogen gas in distant galaxies. Another powerful tool was infrared astronomy. Slowly but surely, a map of this previously uncharted territory began to take shape, one galaxy at a time. It was like putting on a pair of infrared goggles and suddenly seeing warm bodies moving in a dark, smoky room. The empty patch on their maps began to fill up with new discoveries. The hunt for the Great Attractor was back on, armed with these powerful new ways of seeing. As the data from radio and infrared surveys poured in, a clear picture began to emerge from the static. Right in the heart of the region where the Great Attractor was predicted to be, astronomers found a massive concentration of galaxies. It was a monstrous collection of hundreds of galaxies, all whirling around a common gravitational center. The discovery of the Norma cluster was a major breakthrough. To confirm its mass, they used X-ray telescopes to study the superheated gas that fills the space between the cluster's galaxies. However, a new twist was waiting in the wings. The Norma cluster was a beast, but it wasn't beastly enough. The Norma cluster was not the final destination, but rather a massive signpost on the road. Imagine a river system. The Norma cluster is like a major confluence where several tributaries meet, creating a strong current. This larger structure, the true center of the gravitational pull, was eventually identified. It's an immense supercluster of galaxies called the Laniakea supercluster. It contains our own Milky Way, the Virgo supercluster, and the Norma cluster, along with about 100,000 other galaxies. All of these galaxies are flowing towards a common center of gravity within Laniakea. The Great Attractor, then, is best understood not as a single object, but as the gravitational heart of the Laniakea supercluster. Our galaxy is like a tiny boat being carried along one of the many streams that make up the Laniakea river system. This revelation was a triumph of modern observational astronomy. The Great Attractor mystery was solved by redefining the map of our universe and our place within it. Our Milky Way galaxy is caught in the middle of an immense cosmic tug-of-war, pulled in multiple directions by various cosmic heavyweights. The most immediate and intimate of these struggles is with our galactic neighbor, the Andromeda Galaxy. The two galaxies are currently hurtling towards each other at a speed of over 400,000 kilometers per hour. However, this local dance is itself being influenced by a much larger force. The Great Attractor acts like a giant, distant magnet, its immense gravity reaching across hundreds of millions of light years. It is like being a small boat in a complex system of ocean currents, with local eddies and tides pushing you one way, while a massive, deep ocean current carries you inexorably in another direction. Our galaxy's path is a net result of all these competing gravitational influences. Untangling these different pulls is one of the great challenges for modern cosmologists. The influence of the Great Attractor is not limited to just our Milky Way. Its gravitational reach is so vast that it orchestrates the motion of our entire cosmic neighborhood. When astronomers map the peculiar velocities of thousands of galaxies in our vicinity, a stunning pattern emerges. These filaments trace the underlying structure of the cosmic web, the vast network of dark matter that forms the scaffolding of the universe. The Great Attractor's pull has organized the galaxies for hundreds of millions of light years around into this coherent, flowing pattern. This unified motion has profound implications. It tells us that these vast structures, these superclusters, are gravitationally bound entities. This demonstrates the constant battle between the cosmic expansion and local gravity. The Great Attractor's influence is a spectacular demonstration of gravity's power to build structure in an expanding universe. We are part of a grand process of cosmic assembly, where smaller structures are gradually drawn together to form ever larger ones. From our vantage point within the Milky Way, the Great Attractor's influence is subtle but measurable. The primary evidence is in the cosmic microwave background radiation. The CMB acts as our cosmic speedometer and compass, constantly telling us where we are going. The Great Attractor's pull also helps shape the future of our local group. While our destiny is to merge with Andromeda, the entire resulting galaxy will continue its journey. Over immense timescales, billions upon billions of years, our local group will draw closer to the Virgo cluster, and both will continue their inexorable slide towards the Great Attractor. Ultimately, the Great Attractor's influence is a profound reminder of our place in the cosmos. We are not isolated. The matter in a region hundreds of millions of light years away is dictating the path of our galaxy through space. The quiet motion of our galaxy through the night is part of a grand coordinated dance, a testament to the universal and inescapable power of gravity. The view from the Milky Way is not one of stillness, but of a dynamic and ongoing journey towards a great hidden mass. Our journey to understand the forces pulling our galaxy has led us across hundreds of millions of light years. We've peered through the dusty veil of our own Milky Way, mapped the motions of countless galaxies, and uncovered the colossal structure of the Laniakea supercluster. We now understand that the Great Attractor is not a single monstrous object, but the gravitational heart of our cosmic home. Yet, despite these incredible advances, the story is far from over. The zone of obscuration continues to hide the very core of this region from our direct view. And more profoundly, what is the role of dark matter in all of this? We believe that the vast majority of the Great Attractor's mass must be in the form of this invisible substance. Furthermore, the Great Attractor is not the only major player on the cosmic stage. As our maps of the universe have expanded, we've discovered an even larger and more distant structure, the Shapley supercluster. Our galaxy's motion might be the result of being pulled towards the Great Attractor, while simultaneously being pulled from behind by the even greater mass of Shapley. This enduring mystery is what drives science forward. It's the grit in the oyster that produces the pearl. The future of cosmic exploration is bright, and the mysteries of the Great Attractor will remain a key focus for astronomers. Powerful new radio telescopes, like the Square Kilometre Array, will be able to map the hydrogen gas in the zone of obscuration with incredible sensitivity and detail. Infrared space telescopes, such as the James Webb Space Telescope and its successors, will also play a crucial role. By combining these different views of the universe, from radio to infrared to X-ray, we'll be able to build a complete multi-wavelength picture of this critical region of space. Beyond simply observing, theoretical cosmology will continue to evolve. Supercomputer simulations of the universe will become ever more powerful and realistic. Scientists can create virtual universes in their computers, inputting the laws of physics and watching as structures like the Great Attractor form and evolve over billions of years. The Great Attractor serves as a perfect laboratory for testing our most fundamental ideas about the cosmos. Ultimately, each new discovery about the Great Attractor will help us to better define our own place in the cosmic story. The story of the Great Attractor is more than just a tale of gravity and galactic motion. It's a story that evokes a profound sense of wonder about our place in the universe. We now know our address is not just Earth, or the Solar System, or the Milky Way, but the Laniakea supercluster, and we know our direction of travel. The future of this hunt is not just about finding a destination, but about understanding the journey itself. It's a quest that speaks to our deepest desire to know our origins and our destiny. A journey of discovery that is, in many ways, just beginning.